Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you. Now that we're all set up to do our first image classification, let's first quickly recap. We started this little journey mini-series by focusing on or identifying or presenting the tools that's within QGIS that can be used for image classification. And we identified 6 tools, and we're going to use all of those 6 tools. Now, just remember again, each of these tools have different methods, and some of those methods have different parameters. So minimum image classifications we're going to do is the 6, and average is 4 methods. So minimum image classifications, number of image classifications is going to be 24. And then we'll see whether we're going to work within different parameters. We'll have a look. We'll see. But the minimum amount of classifications we're going to do is 24. And then obviously we'll do an assessment to see what tools, what methods perform better, perform not better for my region of interest. Okay, so this is for my region of interest. For your region of interest, it may be quite different. So that is in 180. We did that. In 181, we said, okay, now we've got the tools, we've got the methods, our QGIS is set up. Now we need our image. And again, we can either use Landsat or Sentinel images. In my case, I decided to use Sentinel image. So 181 goes into acquiring the Sentinel image and getting it ready for classification purposes. So that's in 181. And then in 182, we looked at developing or generating our training file or our training image. Because remember, image classification is based on having that training samples for our different classes. We identified 6 classes, and for each class we generated at least 4 to 5 training samples, and that training samples then will be used to do our image classification. So that's done in 182. So now we've got all our ducks in a row, so to speak. We've got all our horses lined up, and we're ready to go. Okay, so before I go, please, boys and girls, remember to subscribe, like, share, comment. I've had received some lovely comments over the last 2 or 3 days, and I really do appreciate it, and I have responded to all those comments. And so thanks, keep it coming. Please forward, please like, please subscribe, please share. It makes a world of difference. Let's get those numbers up. Then please also remember my Facebook page. More than happy to follow me on Facebook page. We will do some work on Facebook over time as well. It's in the infancy stage, so please hang on, bear with me. We'll get that up and running as well. Okay, so there's my channels, there's my information. More than happy to have you joining me on this remote sensing journey. Okay, so this is what we've ended. There's my daytime image. Remember, it's a stacked image, so I'm working with all the bands, all Sentinel bands, okay, from 1 to 12. Not just the first 7, as some people do, all 12 of them. And then you'll see I've generated my training samples. There's my training file. It's in a polygon, it's a shape file. And you'll see there, green is farming, etc. So there's the 6 classes. Okay, so I've got everything ready. Please remember to share. Okay, so remember also I said that this training file we can use in at least 3 of our tools. The other 3 require 4 of the training of the image classification tools. The other 2 requires this file to be in a different format. So we'll first start with the tools that we can use it as is, and then we'll progress. Also, we're going to also look at object-based image classification, not just as spectral signature classification. Anyway, so the first tool we're going to use is Dzetsaka. Sorry, keep on pronouncing this thing wrong.
Dzetsaka classification doc. That's the first thing that we're going to use. So we left click to find it. It's this little magnifying glass, or you can go into plugins and it will sit under plugins. Okay, so either one of the two you can use. So I'm just going to left click on this one and it will open the doc here, open the layer panel here. Okay, so there we go. So now we're ready. Now we're ready. So in our file, our image file, datetime image, we will select our stack raster. Okay, so remember this is our stack raster, this one here. So basically the background, which in this case we're presenting it in true color format 432. But we can also present it in 743, which is a false color, etc., etc. So I'll select that. Then I'm going to select my training file, this one here, and we're going to select the ID. So if we go there to the file itself, we open attribute, there's the ID. So we're going to work with ID. It always require integers and not text. Okay, so it must be an integer that you select here, not the text. And that's it for in terms of selecting these parameters. Then if we click on this nut, I like the word nut. If we click on this little nut here, you'll see there's our options. We can have the Gaussian mixture model, we can have the random forest model, we can, or method, let me not say model. Yeah, model, fine. The Gaussian mixture model or method, random forest, support vector machine, k nearest neighbors. So there's four methods or four models within Dzetsaka that we're gonna run. You can leave the suffix and all these things you can leave exactly the same. Okay, so let's click on Gaussian and let's try that one first. We're gonna do all four quickly. So I've selected it. These I keep exactly the same. There's providers. Keep it standard. It's no point playing around with it. These are just prefixes and stuff. Don't worry about that. And we close it. And then we're going to find okay, so remember it's on a nut, it's selected. Then we're going to find a place where we're going to save it. So go to image classification and I'm going to save it. Just going to give it that. Sorry, I'm just going to give it a one at the back because I've already got it. So we save it. So then it's loaded. I'm not going to hana with this at the moment. Leave it as is. That's not needed for now. We're going to play around with it later. And we say perform the classification. So you say perform and it's going to give you, yes, that was quick. Anyway, you see that was very, very quick. Okay, so there's my classification. There it sits. Okay. And there's my image classification. Now, obviously, we need to now give it some color. Okay, so I'm just going to delete this because I've already done it. So I'm just going to remove it. And there I'm going to go to my Dzetsaka Gaussian. Okay. And I just basically give it a color scheme. Because remember the previous one was everything was gray colors. So in this case, I'm just giving it a color scheme. And I'm using the same color scheme as I used in the training. So farming is green, mountain is purple. Where's mountain is purple? No, mountain is here. In this case, it's brown. So under that purple, like here, I must actually change it. Sand, in this case, is yellow. Urban. Okay, so let's quickly go and say properties. And there we go. Okay, so water is blue. Okay, so let me do this as well. Let me open this. Okay, so you'll see water is 1, felt is 2. So let's go in here again. Water is 1, felt is 2. Sorry. Mountain is 3, farming is 4. Mountain is 3, farming is 4, urban is 5, 6 is sand, bare soil. So that's our classification. So we just gave it a color scheme. You don't want to present it in gray colors. You want to present it in proper colors. So how do we do that? You just sort of right click on it. You go to properties. And then we go to palette unique colors. Okay, select palette unique colors. Remember, there's the options. Remember, there's your single gray. If I do that, there's a single gray that comes out. Okay, so that's how it looks when it is generated. Okay, so we go there and we go properties. We go paletted single, and then we say classify. Then delete the 0 because there is no zeros. So delete it, and there is 1 to 6. Now you basically just double click on the one. We know it's water, so I want the water to be blue. So we select the blue, and there it is, etc., etc. Now I've already generated the color scheme, and I've saved it. So I'm just going to load my color scheme. There it sits, and I'm going to load it now. Load the color scheme, and press OK. And there it sits. Now I've saved the color scheme. So I've generated the color scheme. So what you can do is, okay, so we can go properties again. And you see there's the color scheme. Now let's say I don't want these colors. Okay, I want to have different colors. So for example, so let's say for example, I want the felt not to be this color. I want the felt to be a more brownish color. Okay. And I want the mountains not to be that brown color. I want it to be, let's call it what would be the mountain? Blackish color. So let's do that. Okay, so I'm going to say apply. Okay, and there's my new color scheme. Okay, so what I can do now with that color scheme, because remember I want now consistency with the color schemes throughout all my I want consistency with all my color schemes throughout all my classifications. I don't want this classification to have that color scheme and that classification to have this color scheme, because remember, I want to compare it. Okay, I want to compare visually. So the color schemes all need to be exactly the same. So let's do this again. So I'm going to go properties. I don't want this green. Let's make it this green. Let's do that green and see how that looks like. Apply. That looks a little bit better. Okay, so I'm now happy with my color scheme. Okay, and then basically all I'm going to do is go to properties. So there's my color scheme. I've selected my color scheme, I've platted it unique values, blah, 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 blah. I've got it, so I'm going to save it. So I'm going to go to save style here at the bottom, and I'm going to go save style. And I'm going to save it as, I've already got it. I'm just going to call it class 1. It's saved automatically as that type of file. I press save and OK. So now that style is saved. So I don't every time now have to go and redo the style. I simply just go to the classification and I go to style and I say load style. And it will load exactly the same style. That means you're now going to have consistency within your visualization, within your image classification. Okay, so that seems to work very, very well. Okay. So that is cool. So that's our first image classification of our region of interest. And this image classification, as I said, is spectral reflectance. It's based on a spectral reflectance, meaning let's call it a unique ID of each of these pixels as it's contained within the different bands. It's for winter. What else? Okay, so now we need to look at, visually, see whether this thing makes any sense. And again, if I have a look at it, you'll see there's the true color image, and there's my image classification. First of all, it does seem to capture the mountains fairly accurately. It seems to reflect the agriculture fairly accurately, but it's got a lot of red, and that is a little bit worrisome because red is supposed to be urban areas. So it's struggling to distinguish or differentiate between bare soils and urban areas. You see, there's too much red for my liking. The veld seems fine, bare soil seems fine, agriculture seems fine, but again, this issue of the bare soils and the urban area. I think the water is a bit of a problem. Um, so in this case, it's okay. It's nothing to write home to. It's okay. Um, let's look. We have to put this now in context with some of the other models. Okay, so let's go. So we've got this one now. Save. Okay, so we've got this image classification. It's based on the Gaussian mixture model. Gaussian mixture model. Okay, so let's try the next one. Random forest. We can change that there. I just like to keep it the same. Random forest. The rest I leave exactly. I just change it here to Zenza and I make it random forest. I'd like to keep the Dzetsaka, the name there, because it tells me what tool we were using and then the method. And if we have parameters, I'm going to keep it below. And we just run it again. Perform classification. And it's running. Now this may take a bit of time. The random forest does take a bit of time. So let's just wait for it. In the meantime, as I said, these image classifications are based on spectral reflectance, and that's why your training sample are so important. Your training file are so important to make sure that you capture. Okay, there it's going, and where is it? There it sits. Okay, there it is. Okay, so again, I'm just going to go there now. So it's opened. I'm going to put it in front of the previous one. So we've opened it now. Oh, it's generated the classification. I'm going to say properties, and I'm just going to say load the style. I'm not going to do any of these things. I'm just going to go straight through to load style, and then just go select my style that we just saved. Press open, load the style, and voila. And there it sits. And there it is. Okay, so I've already done this. Okay, so I've already done this, but anyway, I think my style here is a little bit different. You'll see the color schemes are different. That's why it looks different. So that's why you want the same. You see, that's exactly the same image classification, just with different color schemes. You can see the difference that it's making. And that's why it's important that your color scheme are the same for all image classifications. So let's not delete it, but I'm going to delete this new one that I've created or remove it simply because I've already done one. And I'm going to go with my original one. I'm just going to change the color scheme. See, I'm just going to change the color scheme so that it's consistent with the previous one. And we select that one. We load the style, close, and OK. And there it is. So now I have a look at the two classifications. Okay, remember to save. Now look at the two classifications. Which one just visually looks more accurate? The random forest or the Gaussian? There's the Gaussian again, and there's a random forest. Doesn't seem to be a rocket science to understand that the random forest looks much more accurate than the Gaussian one. Simply because it captures the water much more accurately. You can see that. There's the river. It captures that river much more accurately. You can see the Gaussian does not. So there is the first indication, and obviously it captures the bare soil. It distinguishes between bare soil and urban much more accurately. It still has some red where there is, like that for example, where there is no urban areas, but it's very, very minute compared to the Gaussian. You see the Gaussian has got lots more red, which is urban areas. So the Gaussian really struggles to distinguish between urban area and bare soil. And that's why, in this case, the random forest seems much more plausible, seems much more accurate than the Gaussian. Just visually, ne? We're just now visually comparing it. And again, that's why it's important for you to understand your region of interest. The better you understand your region of interest, the better you will be able to generate your training model, training file, your training samples, your classes, and in theory, the better your classification should be. So there's my random forest. So I've also let's go then we select our support vector. So support vector machine. I'm not going to run it again. We change it there and it's lying there. Let me just get the proper style loaded again. Load the style, and you can play around with the style. Huh? Play around with it to see visually, because remember it's a visual inspection now. That visually just present your classification. There is the support vector. You can see the support vector and the random forest is not that different. You see the support vector identifies these areas as mountainous, where your random forest is, yeah, it's the same, but not, yeah. So the random forest is a little bit more a mountain area here, where the support vector is less mountain still. So support vector maybe has a little bit more red in it. But anyway, we can compare these in more detail. So that's our support vector machine classification. And then the last one for Dzetsaka is the K nearest neighbors. Okay, so I'm just going to do KNN for that, and I'm going to run it. I'm just going to change, obviously remember always to change your ID of your saved file there. But that again is up to you. How you're going to label it, how you're going to save it's up to you. Then you just perform the classification, and voila, there it is. Let me just load the style. So properties, style, load style, and I'll find the style, I'll open it, I load the style, and we close it. And there is my K nearest neighbors. So there's K nearest neighbor. There is support vector machine. There's the random forest. And there is the Gaussian. Now, just visually, the Gaussian is last place. And then you can see the similarity and the difference between the random forest, the machine learning, and the K nearest neighbors are very, very small. There doesn't seem to be significant, huge differences between the three of them. They seem to be fairly similar. There is obviously differences, um, but not to the degree that with the Gaussian one. The Gaussian seems to be a significant outlier. So why? One have to understand the modeling, the model itself, the methodology, or the algorithm itself. But in this case, the other three seems to be, I would think, fairly accurate in terms of its classification of my region of interest. Remember, all the classification is never going to be perfect. Simply because of classes that overlap the image itself. Oh, there's a certain issue. You can see the effect of the clouds here. That's the effect of the clouds. So that's another issue, is that cloud we need to get rid of. There's a river there. It captures that river there, the K nearest neighbor. Support vector machine also captures it, but it captures a bit of mountain there. And then the random forest also captures it nicely. So yeah, these three is fairly cool. Now, that's now one thing. What we want to understand now, obviously, is how much of our total surface area is covered by each of these classes. Okay, so we have the image now. So what I want to do now is compare to, say, in Gaussian, how much of our surface area is class 1, 2, 3, 4, 5 as a percentage. And so we can compare to see in which class classify more urban than mountain and vice versa. So how to do that? We're going to simply go to, let me just very quickly, I'm going to close this, I don't know, okay, so we're going to go raster layer, sorry, raster, it's unique values, sorry, um, raster unique values report. So we want the raster unique values report. Okay, so that will generate the values. So I'm going to run it as a batch process. So I'm going to select, there's my Dzetsaka Gaussian, and I'm also going to select my three others. There they all are. Oops, sorry. So there's my Gaussian, my k-nearest neighbors, my random forest, and my support vector. There's my three image classifications. I'm gonna generate the unique values based on the band, and let's let's see whether, okay, so let's save it as a table. So I'm gonna go and image classification. So I'm gonna just go and create a new folder here, and I'm just gonna wait to, we're gonna say it's values, and we're gonna just click it in there, and save. I don't know why it's so slow now. Save. It's 1, 2. Okay, so let's just make it classification, and then we're gonna give it the same name as parameters. So classification of Gaussian, classification as k-nearest neighbors, and we're just gonna run. There they all are, so they're all done. Okay, so remember, it's raster unique values report. Let's close it, open it there, and there is the summary of the report. Okay, summary of the report. You'll see the extent. They all have the same extent and the width. They all have the same pixel count. No pixel is zeros, so there they all are. So now we need to go into our image classification. We're going to go to clip, to values. You see, and why didn't it generate the report now? Okay, so it should have generated. Okay, so let's just do that one there. I'm just going to quickly run it, and it's supposed to give me, there we go. So now that is what I'm looking for. I'm looking for these values. So basically it means that no values is that square meters for, so remember this is a Gaussian, so I'm just going to copy this now. And I'm going to open a spreadsheet, Excel. Okay. And we're going to paste it in there. Oops, sorry. We're going to paste it in there. Come on. Tell you the secret now. Where is this file now? Why can't I find? Oh, there we go. So we used to have to start from total pixel count, the whole thing. And then we go into that and we right click and we say space special. There we go. So that is now, let me just center it. So that's the Gaussian one. Okay. Pixel count, that's the area. So then we're going to go into the next one, and we're going to go, we've got the Gaussian one, we're going to go k nearest neighbors, we're going to run. We're going to go and find it there, and that is now the k nearest neighbors. We do exactly the same for it. We copy, we go into our Excel, and we're going to paste. Oopsie, sorry. Let me just make it a bit bigger and we paste. Okay, so now we're gonna I'm gonna delete the value and just leave the pixel count. Okay, um, so this one here, I'm just gonna go merge is the Gaussian, and this one here, I'm gonna merge is the k-nearest neighbors. So I'm just gonna make it nice like that, and there we go. We know that the total pixel count, I'm just gonna merge that, is that, and this is my classes. So let's just give it a background bold, make it that as well. There it is. So now it's going to get rid of the points and convert it into, so I'm going to go find, because my Excel sees points as text, so I need to convert it into commas. And let's do the same with this as well, otherwise it won't recognize my calculations. And format that as well. I missed that one now. And replace, there we go. And let's just make it nice a little bit. No, um, no decimal places, etc. There we go. Okay, so water. You can see it's got 27, it's got 1,770 pixels for water, where KN has 4,400. For 2, which is felt, 88, and it's got 87. For mountain, very similar. Then for 4, which is, let's have a look and see what is 4 again. For 4, training, open attribute type, 4 is farming. Okay, 4 is farming. So for 4 is farming, so it's got less farming. And look at the difference with urban. For urban, this one has got 100,000, and in this case, it's only 12,000. And then sand or bare soil is not that different, but you can see the difference. So it really, the Gaussian overestimated urban, where this is much more accurate. And that 100,000 is basically the difference. You see there's 2 which is felt, which they confuse the 2. And it gives you the square kilometers of each of. And so we're going to add for, we can do this, just copy. We're going to do the same for support vector machine. And then let me just make that one as size. And we're going to do the same for, come on, why is it doing this copy? For the random forest. So then I've got Gaussian, k-nearest neighbors, support vector, and random forest. Let's quickly do the values for, would we say support vector machine? We run it. Oopsie, no, don't want to go that. We just go to this one, we open it, and there it sits. Now we're going to copy that values into Excel. I'm just going to do it here. And then I'm just going to copy those values and paste it in there. And then go find and change the values, the dots, replace all, and say equals, and then just go like that and do that. Okay, so next one we're going to do the random forest. I think was the last one that we generated. And we're going to do again the same with that. We copy it. We say copy. We go into Excel. Just going to copy it over. And then we're just going to copy that. Paste it in there. Go find and replace, find what, the commas, replace it with the dots, replace it with the commas, and there we go. Just going to delete that, and there we go. Fourth, you can see support vector machine and the random forest, very similar, very similar. You can see urban in the k-nearest is 12,000 or 13,000 pixels. In support vector, it's 10,000, and in random forest, it's 8,000. Water is 4,400, 3,000, 3,000, so roughly about 4,000. So that seems to be fairly accurate. Veld 187, 165, 163. We can get an average of that. 59, 72. Look at that's very similar. Agriculture. So veld and agriculture is most of our region of interest. Veld and agriculture. Now, if you visually look at it, that close, then that makes sense. Let's just do that. You can see veld and agriculture should be. So the image classification, our image classification seems to be okay. Let's just make that. And this would be, we're going to say Dzetsaka. I don't know, did I do that great? The Z, yeah, I keep on getting this wrong. The Dzetsaka. Okay, so that's our method. It's the red and that. And let's give that a little background there. And there we go. And that shouldn't be there. So let's just quickly go that. Oops, it doesn't want to do that. So what we're going to do is go no borders, and we're going to go back and give it a border. So there is my Dzetsaka model. There's my classes. And there is my 4 methods within the Dzetsaka, 4 models or methods within the tool, Dzetsaka tool, and that is the image classification. So let's quickly go and save this, and we're going to continue working on that now. Image classification, and that is, let's go classification, and we will save it. And there we go. So the next one, next tool, we're going to do exactly the same. Next tool, next tool. So we're going to keep on building this spreadsheet so that at the end of the day, we can most probably just use an average or median to get to the value, to say, okay, let's get the best of all these ones. Anyway, there is my first set of image classifications. Now in the next video, we're going to play around with these things and see what does these options do. How do they add to our image classification? I'm specifically interested in the confidence map, because that's sort of give us, you see, create a confidence for each classified pixel to see whether they, how accurate is our classifications. Save the model, so if you want to use it next time, save the matrix. So we're going to play around with these parameters to see what the outcome is and how we can use that in our image classification. So boys and girls, that's the first one. That's a wrap, as they say. First one done and dusted. And as I said, I think it's very interesting stuff. I think it's very cool to be able to do this. Now that we've got all our ducks in a row. So with that said, thank you very much for joining me. I hope you enjoy this series of videos on image classification. Thanks for sharing your wonderful comments and stuff. And I really appreciate it, and your well wishes. It's very nice to hear, and it keeps the channel growing. It keeps the channel going. So with that said, I'll see you on the other side.